Hello and welcome to our last class for this particular chapter. Exercise 5H is what we're doing. We're finding the volume of a cylinder. Now up front I need to say that what I've written here is wrong. A cylinder is not a prism. But we're going to treat it like a prism because if you can remember, a prism is a shape that if you go from front to back, let's just draw this in carefully. If you look at it from front to back, the area of the front part of the shape is the same as the area of the back part of the shape. And it's also the same as if I actually took a cross-section anywhere through it. The cross-sectional area is the same, all the way from front to back. That's what defines a prism. Now, it doesn't matter whether it's rectangular or triangular or some other shape. But the moment you do something like this, let's join that up. And this is called a cylinder. The moment you do something like this, yes, if I look at it, let's say the area of the top is a circle. The area of the bottom is a circle. And if I actually went through and took a cross-sectional area, that would also be a circle. It's a circle all the way from top to bottom. But strictly speaking, a prism doesn't have any round edges on it. They have to be straight sides. So we treat it like a prism, but strictly speaking, it's not a prism. Now remember, our volume is measured in units cubed. So let's just have a look at our cylinder. Our cylinder has a circular base, circular top. It's a circle all the way through. The radius we know, all the way across would be called a diameter. The height is the height of the cylinder, the distance from the bottom circle to the top circle. The formula for a prism is the volume is the area of the base, or the area of that front edge or bottom edge, it doesn't matter what you call it, shape, times the height. What's the area of our base? It's a circle. Now the formula for the area of a circle is pi r squared. Now I don't really want to put brackets and a times there. I can just rewrite that as pi r squared h. And that's the formula for the volume of any cylinder if I want to find it quickly. So in your booklet you've got a cylinder, you've got a picture of a cylinder, and there's your formula to find the volume. We also have a reminder about capacity. That's how much water or fluid or liquid that we can hold. And we've already mentioned that a centimetre cubed holds a milliliter of fluid. 1,000 centimetres cubed holds 1 litre of fluid. A metre cubed holds 1,000 litres or a kilolitre. We've mentioned that in the previous exercise. We've also talked about converting between different lengths when we're talking 3 dimensions, so different units such as centimetres cubed to metres cubed, so we know how to do that. Let's look at our first example. So when I'm going to look at this shape, I know it's a cylinder, and the formula for the volume of a cylinder is pi r squared h. But 5.4 metres is the distance from one side of the shape all of the way across to the other. So when I look at this particular question, the radius is not 5.4. I have to do half of 5.4 to get the radius because the diameter is 5.4. So half of 5.4 is 2.7, so that's my radius. So in my formula now, it's pi times 2.7 squared times the height, which is 3. Put that into the calculator, and the volume of this particular cylinder is 68.7 metres cubed if I round it to 1 decimal place. Let's try example number 2. This one's actually easier than example 1 because they give me the radius instead of the diameter straight up. So the formula for a volume of a cylinder is pi times radius squared times the height. So this becomes pi times 3 squared times 4. Plug that into the calculator. and I get 113.1 cubic meters if I round it to 1 decimal place. That's the theory behind this. It's now time for you to try questions. When you finish this exercise, you have finished chapter 5 and you're ready to start revising for your tests. So have fun, and if you've got any queries, please make sure you ask for help rather than just not know how to do it. Bye for now.